some of the review packet together, but there's some things that we need to make sure that we are all very comfortable with and confident with for next time we meet, because that's when you have your first unit exam. There is one page, sorry, it's 2 pages, whatever, single-sided, that are front and back, or sorry, front only. So there's like, I think 6 to 8 questions, calculator free, and then 6 to 8 questions that you're allowed to use your calculator. You'll come in, you'll pick one up, you'll get started. You have, and I'll let you know about the halfway point, as to when you should be sort of transitioning between the pieces on the test. Don't get stuck on a question. I'm going to have a ledge up here, and it's going to say like 1 through, I think, 28 here, and you will leave your phone there to make sure that there is no distributing of the questions and or taking pictures of the test, which is apparently a thing. The other thing that we will that will have to happen is if you have to go potty, you need to go beforehand, because when we had a breakdown before, we asked just anonymously how many of the kids left a formula sheet in their pocket when they went to the bathroom, and it was over 1 out of 4. So make sure, please, that you go potty beforehand. We also have a treat in here. If the urge is overwhelming, I guess, in class, not really, you don't want to kill the treat. If we've gone through and done it, it's a candidate for a question. The stuff that you need to make sure that you're familiar with is domain and range. We need to know functions and one-to-one functions. We need to know all of that stuff that you did in Geo about equations of lines. You need to know compositions of functions with expressions and with numbers. That's when we take the inside function and plug it into the outside function. We need to know how to add, subtract, multiply, and divide functions. You need to know how to do piecewise functions, and you need to know about inverses and their properties. The answers to this review packet are going to be posted. We're going to hopefully burn through some of these questions quickly and then get to some calculator review stuff. But again, don't sell yourself short and give me the garbage that you're a bad test taker. There's no such thing. There's no such thing. If you feel nervous about the test, that just means you need to study more. That's your body saying you're not as ready as your brain thinks you are. Because if you're very confident about something, I can guarantee you can do it over and over and over again. So just make sure, please, that that's the case. Now, somebody had asked a question previously about what's the difference between a discrete and a continuous function. That was, what question was that? No, was it 4 on that sheet? So the question 4 from that sheet that you had the other day where I said, type it into Google. I typed in, I think, what's a discrete function in math. A continuous function is one such that every value of x is taken on and it will yield an output. When we're talking about examples of continuous functions, a continuous function is one where every x that's available is taken on. A discrete function is one that has some type of restriction on it. So if I were to go through and say, what's the number of students in this class? It's impossible for us to have 8.6 students in class. Why? Because I've never seen 0.6 of a student walking around. Like you can't have 11.2 deer. Deers? I think it's deer. 11.2 deer, because you can't have 0.2 of a deer walking around. So that's an example of something that would be discrete versus continuous. Now, this was the review sheet that you went through and picked up. We'll do some of these questions. Take a look, please. Hands up, please, if you can tell me what the domain for number 2 would be. What would our domain in number 2 be? So 3 people, ready? To ruin someone's morning. Let's see. Chloe, what do you say our domain in number 2 is going to be? Hands up, please, if you can tell me what our range in number 2 would be. This hopefully is a little bit easier. What's that? Sometimes you'll have to go through and state what it is without looking at the calculator. You should be able to figure this one out. This is an absolute value graph. Hopefully you did them before. They look like V's when you graph them out. What is the domain, though, of this? Hands up, please, if you can tell me what the domain. Again, you don't need to go into the calculator to get this out. What inputs will yield an output? What do you want to say? Terrific. Terrific. The domain would be all real numbers. Now think about the range values. Again, we're not looking at the calculator. It's an absolute value function. What do we know about absolute values? There you go. Our range would be from 0 out to positive infinity. Questions on that? Again, the answers to this will post through Google Classroom. Take a look at the next one at number 5. I'm only going to ask you about the domain, and I'm going to specifically say you don't need a graph to do this. You have to engage yourself. You don't need a graph to do this. In number 5, who can tell me what values are not going to be in the domain? We have 4 of you. That's it. Look at the function that's there. Who can tell me what values will not be in the domain? -3 and what? Careful. You're partially correct. We know that -3 is not in the domain. Is 2 in the domain? Two is in the domain because it just causes the numerator to be 0, which means your range value would be 0. So if we were to state what our domain is in interval notation, it's -infinity to -3. I need to jump over and resume. Then -3 to 3, jump over and resume. 3 to positive infinity. That would be your domain. Because that means it's everything, but what 2 values did I jump over? I jumped over -3 and 3. What mistake do you think people will make? They're going to omit that middle interval. 0 is in the domain. -1 is in your domain. So you need to account for those values. They're going to give you an output that may be awkward, it may be ugly, but it'll give you an output. How about for 6? Without looking at the calculator, who can tell me what our domain in 6 would be? Think about the inputs that will give you an output. Try some values, say when I plug this in. Because again, this would be a question that's perfectly legitimate to expect as a calculator-free question. We got 1, 2 people that can tell me what the domain in 6 would be. 4 of us. Don't stare at it. Start plugging in X's and say, will this give me an output? It doesn't need to be a pretty output. Will this give me an output value? We've got 4 of you. We know that 3 is sort of our transitioning value, and 3 and up is going to work. Now we're going to have an awkward question. Normally, I would say that 3 would be in the domain of this function if it was just the square root of x minus 3. Why is 3 not in the domain? Because 3 will give you an output from the denominator. Perfect. Absolutely perfect. It would make your fraction undefined. That's terrific. Questions on that? How about for number 7? When we look at number 7, that's my f of x and that's my g of x. We need to find g of f of -7. What would be the first thing, Emily B., what would we go through and do to start this off? Okay, so let's find f of -7. Hands up, please, when you can tell me what the f of -7's value is going to be. We've got 4 people. Melissa, what did you get? Hang on, what did you say it was? 55, yep. What would you do next?
Plug it into the F and
Perfect. So we go 7 into the F, then into the G. So I'm going to take the G of 55. So this is where it's going to get a little bit. Now, by the way, if you need to evaluate out a function, here's a little bit of a trick, and hopefully make sure you signed in to your calculators. I'm going to show us a little bit of a trick quickly that makes it so you won't input something wrong. What we're going to have you do now is this, go into a new document, and we're going to add calculator. And what we're going to do is we're going to evaluate out the, was it a G or the F that we're evaluating with the 55? G, all right. So I need to put the G expression in. I'm going to type in the expression though. So I'm going to do control division to get the fraction. And then in the numerator, is it x plus something? Plus 7? X plus 8 over x. All right, so type in the numerator x plus 8. And we're going to divide that by x. Then go outside of that, please. Now, we talked about this feature. Now, normally I would say you could do this by putting parentheses here and inserting, parentheses here and inserting. Another way to get a quick evaluation that's less parentheses is to put in the expression, hit Control equals, and you're going to select the bar. And now type in x equals. What did we want the x to be replaced with? Was it 55? Okay, so let's do x equals 55 and press enter. And it's going to give you what that is with the 55 plugged in. So you don't need to worry about the parentheses. Right? That's an alternate way of doing it. Did you all know about that or no? Did you know how to do it? Okay. That's another way of doing it. You could have replaced them with parentheses. So our answer comes out to be 63 over 55. Questions on that? Take a look, please, at A. There is my h of x, and there is my m of x. And what we're in charge of is taking h of m of x and taking m of h of x. By the way, there's another way that we could be writing this, and we could list this out as or, and then in parentheses it looks like h-o-m. If it's an open circle, it's a composition of functions, and you're plugging one into the other. If it's a closed circle, try to make this. That means well, we'll ask this. Jeff, which function's getting inserted into the other? Am I putting the m inside of the h or the h inside of the m? So let's take our m function, which is right here, and everywhere there's an x, you're going to put parentheses and insert the other function in. So this is going to go in here, and when we list it out, I'd say parentheses minus 2 all over 4, and in that parentheses spot, I'm going to insert the other function, which is 2x squared plus 4. So once I get to this point, let's see. Trevor P., what is the numerator going to simplify to? Look at the numerator. You got 2x squared plus 4 minus 2. Put your like terms together. What's that going to leave you with?
So 2x squared plus 2.
Okay, over.
4.
Is that our final answer? Who sees something that you can do on this? Yeah, the GCF, that means everything shares it. What can you divide out or reduce out from the entire expression? 2. So what would you list out as your final answer? No, we can divide it right out, because it's just a constant multiplier. So what would you get if you divided everything by 2? Does the numerator factor down? No, it would if it was a minus. go through right now, please, and do out B on your own. You can tell me, please, which function is getting inserted into the other. Take a look at what's there. Which function is getting plugged into the other? We've got one person, two, six. So what would you write out? Now, before we give up and you go, oh, I can't do this, this is challenging, that's baloney. This is going to be 2. Now, we can square this. This is going to be, by the way, what do you get when you square the denominator? What's that going to be? Hopefully we know that's 16. It's concerning if we don't. Take the quantity x minus 2 and square it. Take the quantity x minus 2 and square it. That means this. What do I get if I take the quantity x? We've gone over how to do this. What would I get if I took the quantity x minus 2 and squared it out? Noah, what would you have?
X squared minus 4x plus 4.
There you go. It's a FOIL question or a magic box or whatever they call it. Now, we can go through and keep going. This is saying 2 times this expression over 16. I see something I can do right away when I'm doing that multiplication. Something that I could do that's going to help me go forward. Tyler? We can reduce this down. What's 2 over 16? So remember, it's 2 over 1. What's 2 over 16 the same as? 1 over 8. So I've got x squared minus 4x plus 4 all over 8. And to that, I need to add 4 over 1. Again, an honest lesson. I've got my fingers crossed we can do this. In order to add 2 fractions, what criteria needs to be met? We got 1, 2. We're going way back to scribe. Go ahead.
Common denominator.
What would your common denominator be? So what is this? What is 4 if I express it as a fraction with a denominator of 8? What would the numerator be?
32.
Now that these have common denominators, can I keep going further? Hands up, please, when you can tell me what your final answer is going to be. Go ahead.
X squared minus 4x plus 86
Yes. You always got to look to keep going. And yes, we're expecting you to do things like reduce 2 over 16 and things like that. That's all math that you can do. You're very, very bright people. Take a look, please, at question 9. Looking at question 9, the first thing that I want to make sure that we know is what type of graph would 9 be? So Emma asks, what type of graph is the equation in 9 going to be? What shape is it going to take on? It's a parabola. When we're talking about the inverse, we have to take into account whether the original is 1 to 1. So Emma, is this 1 to 1? Yes or no? No. Why not? Is it a function too, sir? This is a function. Is it a 1 to 1 function though? And why not? Perfect. It fails the horizontal line test. What do we know about the inverse then if we have stated that the original is not a one-to-one function or it fails the horizontal line test? What do you say?
The inverse wouldn't be a function.
Does the inverse exist? Yeah. Is it going to be a function though? No, because remember, if our parabola goes like this to start, it's going to be sideways when we take its inverse. What's our first step in taking the inverse going to be, Haley? Terrific. So what would you write out? Can you keep going? What's your next step after you switch to x line? Can you keep going? And then? So I would go through and say y inverse is, notice I don't say f inverse because the original doesn't give us function notation, is equal to the square root of the quantity. Is everyone okay with that? Why do you say no? Smartest person in the room.
We'd have to square the 7 square root of x first.
No. This though is not right. This is not correct. So what do you need to do to get the other half of the inverse? If we had restricted the domain on the original, you'd be right. We did not. Let me just ask this. If I'm solving this for y, right, and see how it's a y squared? If I'm solving this for y, this exponent tells you how many answers you should get. So when I'm solving this equation for y, I should get 2 answers. Somewhere along the way, though, I only have 1. Now, this notation doesn't mean y to the negative first power, it means y inverse. It has to be plus or minus in front. If you take the square root, it's plus or minus. Did they go over with you before that the exponent tells you the number of answers the equation's going to, okay. The exponent gives you the number of answers the equation's going to have. That's why you always need to take that into account. Like if something's cubed, how many answers should you get when you solve that equation? 3. And if it's to the 7th power, you know that there's 7 answers to it. The highest exponent is the number of answers that we would go through and have. How about, please, for number 10, what would we do, Taylor, what would we do to get an answer in number 10? Okay, so let's take g of -5. Hands up, please, if you can tell me what g of -5's value is going to be. Okay. Can you keep going, please? What you would do after you got that 23? So let's plug it into the f. So we're going to evaluate out f of 23. 2 times 23 is going to give you -46. 46, that's negative. And then we would subtract 7. So 46 minus 7 is going to give you what? -53. Right? So when we're talking about questions, just so you know that are calculator free, this would be one that's perfectly reasonable to do without the calculator. Now, next one up here. Let's find out what our domain and range on this is going to be. I would say for something like this that the calculator would be permitted. I'd say you probably are going to be able to do it. I don't want to presuppose. Go into your calculators, please. Let's have you graph this out. So, did we talk about how to get a new problem as opposed to like scratching everything out? So go in and let's add a new problem. So notice it goes 1.1 to 2.1. And didn't we get that by going to menu and something like that? It was like file or something like that. Insert, right? And it was a new problem. So we're gonna add a graph, which is 2. And so from there, I would go through and input, is it 5 times the radical of, or the square root of, x plus 8, and press enter. All right, so here's one too, where we're gonna get into something, instead of doing some egregious zoom, let's process for just a second what we need to see more of and what we need to see less of. In terms of the x's, those are fine. I need to see less of what's down here and more of what's up here. So let's go in, again, you could manually do some zoom, but you don't need to. I mean, hopefully we're smart enough. Go in and press menu. Let's change what our window is. So go to 4, and we're going to go to window settings. Our X, min, and max will say that those are terrific. How about we change our Y min to be -1? Who can tell me what they want to make? Give it a guess. I don't even know what's going to be a good one. Who can give me a guess as to what a good Y max you think for this would be? What do you want to say? Let's try 15. And if if it's wrong, you go back and you change it. Okay, so not bad. We can do a little bit better. Who wants to give another one that we want to try? 15's that's not a bad guess. It's within the realm. Yeah. Let's try 25 and see if that gives us a better one. Is that a little bit better? Yeah. So now you've got a really good idea of what's happening in that graph. You did it wrong? Try again. So let's go through now and answer some questions on this. What is the domain in 11A? Courtney, what do you say? So I will go through and say that my domain is, hang on. And you said -8? Okay? That's terrific. You got it right. Yes.
But I don't feel like we really need the calculator.
You'll have it for this. Some of them you won't. Once we do transformations on parent functions, you won't have the calculator.
Okay.
Take a look at the next one.
And I can do the range as well.
Well, hang on. Oh, domain and the range. Let's do this. Without graphing this, though, you should have been able to answer the range. Can anybody tell me what range value or what the range on this would be and why you know it without having to graph it? Got 4 of them? You should be able to say what the range is going to be and why you know it without having to graph it. Jason, what did you say?
I said square bracket 0 and then a regular bracket or regular parenthesis positive infinity.
Why?
I said that awkwardly. But the reason why I say this is because every square root function, unless indicated to outside of the radical to go minus or positive, will indicate that it has that range. So since there's nothing outside the bracket that says to go up or go down, then it would just be 0.
0 and up. The reason being, think about the values that you're getting as the output from a square root function. As of now, you can't take the square root and get an output value that's negative. That doesn't mean that the range of every square root function will be 0 and up or 0 to positive infinity. What could I put on that would cause me to get a range of negative infinity to 0? You can tell me it's possible to have a square root function such that the range would be negative infinity to 0. What would need to be there, though, in order for me to get that as an output? Well, you'd have to have some negative coefficient. And furthermore, we'll talk about shifts and things like that. So the next thing that we're going to do is find out what our inverse is. Now we're going to promise, I guess, from our algebra. Here's my original equation, 5x plus 8 here. Let's find out what our inverse is. So, Allison, what would you do to get your inverse? So what would you write out? Can you keep going?
Then we will divide by 5 on each side.
Keep going.
Then we square each side.
So what do I get if I square? And again, at least from Regents kids, they struggle with this. I don't know how comfortable you are. Do you know what this would be?
Square 5 by 3.
Perfect. You got to remember to square both components. That's going to leave you with y plus 8. Now over here, I would go through and subtract the 8, so I'd be left with x squared minus 25, or over 25 minus 8 is going to be equal to y inverse, which is the same as our inverse function in this case. There's one problem, though, that we're going to have. When we took the square root of this, when we took the inverse of it, what did we arrive at? What shape is this going to be? If this right here, this expression is our inverse, who can tell me what shape this is going to be? A parabola. Is the original going to be, think about the original, what shape is that? Square root graph is half of a parabola. So we need to restrict our domain down. Go into your calculators, please, and let's plug in 3 graphs. We're going to start a new problem. Go in, please, and what we're going to do is this. Go in and plug in the original graph. And by the way, how can we see what we're looking to take the inverse of? We plug in y equals x is our second graph, and then our third graph is going to be what we got for an inverse. So there's our first one, our second one, and our third one is going to be what we got for the inverse. But we're going to need to restrict its domain down, and we'll see what happens when we do that. And again, you probably are going to need to modify your window. And I think we were comfortable with everything staying the same, maybe not so much with the y, but bouncing it up to be, yeah, we're going to need to make that bigger. So go to window settings. Our x-min and max are fine, but our y, and we need, by the way, the y-min to be a little bit lower and our y-max to be a little bit higher. You want to do like negative 25, or let's say, yeah, that's a little too low, but we're okay. Let's do negative 15 to positive, was it 25 that we used before, or 50? 25, all right. So press OK. Now, this is just slightly hit a scale by 2. Since it's not a 1-to-1 ratio, it's going to be a little bit awkward. What do we need to restrict our domain to be? So this gets mapped onto that. So we need to make sure that our x's are, because this piece here is the inverse of that piece here. So we would need to restrict that down to be from x's 0 and beyond. Let's ask this, how about for C? What's the domain of C going to be? Or sorry, what's the domain of our inverse going to be? Maddie, what do you say? Take a look at our inverse. What would the domain on that inverse be? Let's do this. Here's one way to check. Here's one way to check. Go back up to the original. What's the domain of the original? And look at the range of the original. What's the domain of the inverse going to be? Other way around, 0 to positive infinity. And then what's the range on that inverse going to be? By the way, that's how you, another way besides looking at the graph, this is another way on how you could have arrived at the domain restriction on the original. Yes?
So whenever the range of the inverse, you will get the restriction.
Yes, you have to, because remember we gave too much. Remember how it's going to be a huge parabola? And that graph, the one our original didn't have that. It gave too much. And just so you know, we looked at the graph to see it, and it was a little tough to see because it was skewed. If this is your domain of the original, and this is the range of the original is the domain of the inverse. So you didn't even need to go through and look at the restricted domain, because this range here is going to be your restricted domain here. It's the same thing. This range, where did it show up again? Right there. Yes?
Maybe if I get those to the human, like
What's that?
I feel like they were easy for the minus one, right?
You just write it after the expression. Because this right now, this here, so, I mean, in reality, you technically don't need that little step, because you could jump right over to this. So if I state this as my inverse, this, as it's written, is too much. Because this, if we don't put a restricted domain on it, means that the inverse has an unrestricted domain. It's all x's, but is that the case? No, it would only be the case if the range of the original was from zero to, was from negative infinity to positive infinity. Now, let's do this. I mean, you can answer. Is f inverse a function? Explain. Well, this is a good one too. You could make the argument either way. Is the inverse going to be a function? Is the inverse a function? You say yes. Why? I'm going to say this, and you got exactly what I was hoping we got to. It is as long as we do what? Otherwise, we've made a mistake in doing it. You've given too much. Okay? Now, we'll say this. And some of these, especially when we're done. Take a look at 13. 13 is different than others. What is it asking you to do in question 13a? Take a look at what's there. What is it asking you to do in 13a? We have one person, two. Perfect. I would take and find the product of f times the g. So I'd say the quantity 3x plus 2 and 7x plus 6. Go through right now, first outer inner last, the rectangle of fun, whatever you want to use. You can tell me, please, what you get when you get it. Jonathan, what'd you get as your answer?
21x squared plus 32x plus 12.
I'm sorry, you said 32x? Okay. Is that what we got? Correct. What is it asking us to do, please, in question 13b? Got one? I'm not trying to hide it on you. What do you think we do in 13b?
Up to 7 minus g7.
Perfect. So let's go in and take f of 7 minus g of 7. What's f of 7's value going to be, Tyler? All right, so you said 23 minus. What's the g of 7 value going to be, Jess? And now I need to do 23 minus 55. can tell me what that number is going to be.
Negative 42.
Questions on that? Write the equation of a line that passes through those points. In order to answer that, what would I need to find first, or what information do I need that I currently do not have? Got 3, 4, 5 of you. Eli, what do you say? How do you find it? So now that I've found my slope, Michael, what would you do from here? Some of you are fighting me on this, and I don't know why. If you use this every time, it doesn't matter what point you pick. You can use a y-intercept. You can use every single point. Now, there's multiple correct answers for this. What do you want to say, Jensen, is one answer for this?
One of the answers would be y minus plus 3
Okay.
equals 4 over 9 times the quantity x plus 4.
You've got a different answer.
It says y minus 1 equals 1 minus minus x minus 5.
Find the equation of a line parallel to that one passing through that point. Alexa, what would you do to answer that one out?
You have to plug in the x and
Okay, so what would you write out? Find the equation of a line parallel to that. What do you want to do?
you do y minus 1.
Y minus 1, okay, equals
2/3 quantity x.
parallel means you use that slope. Perpendicular means you have to do what? Negative reciprocal, so they meet at a 90-degree angle. Here's another one. Find the equation of a line that's horizontal to this. I'll tell you right now, for these questions, I always graph it out. I know it goes through the point 2, negative 3, so I'm going to go over 2, down 3, put a dot there. It needs to be horizontal. So which direction do horizontal lines go? Hands up, please, if you can tell me. Side to side. So I'm looking for the equation of a line that goes something like this. Now, is this an x equals line or a y equals line? Hands up, please, if you can answer that, please. And it's going to be, in this case, y equals what? All right. So what we'll do now is this. And let's, even though I hate them, I've started to hate them with a passion. Take out those book computer things that you all have right now. And please do that and log in to Google Classroom. And let's see if we can get this done together. So you'll see here, currently posted, you have, if you were to click on it, remember how I gave you that sheet with the mid-unit checkpoint on it? If you click on it, here's all of the answers done out. Every one of them. So you can see whether or not what you were doing was correct. The other thing that we'll do right now, so you can see it, and I'll make sure that I do it right. Um, Create announcement, and we'll make it so all of you get it. Um, File. Oh, upload. We'll do this. Where did it go? Oh wait, that's the wrong thing. It's in here. Enriched. Maybe it's in here. Resource. Did this come up to you all right now? Good, maybe it's broke. It's there? Click on it so I can see.
Review packet.
Yep, and then if you go to the last 2 pages, what do you think you're going to find? Okay, all of the answers to the questions. Now, sometimes they use you all would be expected, excuse me, to use interval notation. The biggest thing that we need you all to make sure that you have is just a little bit of confidence when we're going through and doing these out, because you have to understand, you all are very, very bright people. The problem is you get so stressed out. Are there going to be questions? I'd be shocked, by the way, if there were a slew of 100. On any test, that's not the goal. The goal is for you, you should though be scoring, I say this, be and feel good about getting an 85 or above. Like that's my kind, even an 80 I'd say, and above. Because in reality, I'm throwing the kitchen sink at you. I will give you the toughest questions, and it's an examination of how much you know. Again, if you would you go through and take, and does an 80% on the medical boards get you through, yes or no? If you get an 80% on the AP calculus exam, you would be in the top 3% of students in the country. 3% of students get an 80. 80% raw score. Okay? It's not, in order to get a 5, which is the highest score that you can get, you have to get a 63 out of 108 or above. Okay? So understand, yes, it's difficult to get a 100. Some of you are, that's another one. I got 108 on an exam. You can't earn more than is offered. It's like saying I worked today 25 out of the 24 hours today. Is that possible? No. There's a limit on the number of hours in a day. Just like a percentage, it can't exceed 100. That means that you stole points from someone else on the test. Reach over and say, if you got a 108 on your test, that's because you looked over to the person next to you and stole 8 points from them. Right? That's the only way that that's possible to have. Show your work. Be clear. If it asks you to give out an explanation, think your way through. Don't rush. And if you feel nervous, that's fine. Now, that means you just need to go back and review every video of every class that we've done since the first day that you were blessed with my presence is available to you to go through and watch. Every one of them. I want you to do so well. I want you to do so well. And you're great people. I have no doubt that you will. One thing, I guess the only thing I'd say, here's one that's a good question. What if we had would I have to go through and do if I were to take this? Hands up, please, if you can tell me. What's that going to look like when I make that insertion? We're not going to go all the way. We got 2 people that can tell me what the setup on that would look like? No? What do you want to say?
You would put 2x, finding 2x minus 1 square plus 3 times finding 2x minus 1.
And distribute it out. What if I gave you, or asked you to evaluate out f plus g of a? What would that look like?
Oh, it would probably look like 2a minus 1, in parentheses obviously, and then, or parentheses, a squared plus 3a.
Plus
3a. Wait, what?
is that we're trying to add the 2 functions.
Yeah.
And then you would go through and add them together. Look at those operators. This, by the way, these are not the same thing. What is this telling you to do between the functions? This is telling you to insert one into the other. All right. Now, another thing that you all do a profoundly poor job of, you're going to put the calculators back in the right spot and push down on it, please. Before you go, if you want to slide over, we've got tons of papers for you that need to go back. So slide over, please. Actually, well, here's, you can hand out some of these. You can hand out some of these out. We'll get you back some of them. You can hand those out. We're not going to get a chance. Whatever guys, you're not going to have that much time. This is the end right now, right? Sorry. Put them back over here. I'm sorry. If you want to get your assessments, you're free to go through and pull them out from the bin at any point. Sorry. I thought we had more time. I talked too much. You probably agree.
See you, Mr. Matt.
We'll see ya.